All right, so today we're going to continue working with graphing polynomial functions. And as a quick recap, what we talked about yesterday is we noticed that anything with an even degree had the same type of end behavior as a parabola. So we noticed if we had a positive leading coefficient, our parabola was open facing. And if we had a negative leading coefficient, our parabola was down facing. And we talked about how anything with an even degree has the same end behavior. So as kind of a reminder, what we're talking about with end behavior is we're talking about the end of the function. So we're not concerned with what's happening in this middle portion. We're just concerned with what's happening as the function approaches positive infinity, or excuse me, as x approaches positive and negative infinity. So if I wanted to describe the end behavior of this function here, we would say as x approaches infinity, f of x also approaches infinity. And as x approaches negative infinity, f of x also approaches infinity. So we have both ends of our function are approaching infinity. So they're both going up to infinity. Okay, let me make a better one. There we go. For our leading coefficient that's negative, we would say that as x approaches infinity, f of x, our function, is approaching negative infinity now, so it's pointing down. And as x approaches negative infinity, f of x approaches negative infinity. So we notice that both ends of our function, when we have an even degree, are the same, they have the same end behavior. Okay, they either both point in the positive infinity direction or they both point in the negative infinity direction. Okay, and again, we can distinguish between that leading coefficient, whether it's positive or whether it's negative. So that's an even degree. We also looked at an odd degree, so an exponent that might have an odd number. We know that it behaves like a cubic function. So the cubic function we graphed earlier this week with a positive leading coefficient, it is increasing across the entire domain. And then with the negative leading coefficient, we notice that the function is reflected and it's decreasing across the entire domain. So if we went ahead and described the end behavior of all functions with odd degrees, we would say as x approaches infinity, f of x is approaching infinity. And as x approaches negative infinity, so this way, we're traveling this direction, f of x is approaching negative infinity. So we can see that with a cubic, they are going in opposite directions, the end behaviors are. So similarly, if we have the negative leading coefficient, we would say they are still going in opposite directions, but is switched from our positive leading coefficient. So we could say as x approaches infinity, f of x in this case approaches negative infinity. And as x approaches negative infinity, f of x is actually going towards infinity. So again, with our cubic or our odd degree polynomials, the end behaviors will be opposite. And we can see the difference between a positive leading coefficient and a negative leading coefficient. So again, odd degree polynomial and our even degree polynomial. So this all follows the behavior of x squared, and this follows the behavior of x cubed. All right, we also talked really briefly about how we can write our functions in in intercept form. So when a polynomial is in intercept form, it's really easy to tell what the x-intercepts are. And we know the intercepts, another name for intercepts are the zeros. So in this case, we would say the solution to this polynomial, we would have a 0 here, where just x is 0. We would solve this expression for 0, and we would solve and we would get This 0 produces a -1. And then if we solve this one by setting it equal to 0, we can see that it would produce a +1. So we have 3 zeros for this polynomial. We have x equals 0, x equals -1, and x equals +1. So again, those are called zeros. They're also called x-intercepts. They're also called roots. They're also called solutions. Remember, lots of AKAs. So we have to be familiar with all forms of our word that mean x-intercept.